Hi, this is Steve. I'm the founder and CEO of Allied Scientific Pro in Gatineau in Canada. So we are a company that integrate photonics component and make systems, including optics, laser source. So we have a full engineering staff, and we make a product and we commercialize them on the international market. For industrial application or any other commercial application.
Hello, my name is Rez Mani. I'm from Allied Scientific Pro, and today I want to demonstrate to you how you can measure with NIRVAScan spectrophotometer ingredients of fruits, pieces of fabric, and also fat in body parts. So this is just a demo software, and this is the NIRVAScan instrument over here. So we have it here in an iPod Touch. So here is our software icon, DeepScan. This is the app icon. It's called DeepScan. So you just go there, and we would go to the setting first of all to see if it is connected. So let's go to the setting. It's connecting to the cloud, so basically all the calibration curves are in the cloud. So here's goes set by nano, so you can see that it detects the serial number for this instrument. So once it detects that, then we can go to the home button, and then we would it would actually download some reference calibration data from the cloud, and we would start with fruits. And you can see for fruits we have 3 calibration files: apple, mango, and date. So we have apples here. We try with 2 different apples. It should measure the glucose content in bricks. So we would just put the instrument on top of the apple, and then I redo the scanning. So it's the scanning, and it got the spectrum. It compares it with the calibration, and it came up with 14.7 bricks and terms it at very sweet. So next one, we tried a different apple, and you also see that the lights are coming out of this when I press this button. So it measures the reflectance from the surface of the apple. So this is the second apple. You can just see that the lights are coming out, and it's receiving the data, and it's 15.1 bricks. So this apple is sweeter than this apple. This is the result of this test. Now we try with different types of fabrics. So we just go back to the fabric calibration curve and choose cloth and try with the pink. Press the button. So it's receiving the data. This is the kind of curve it gets, and it says 12.6% cotton. Now for the red one, we just repeat the same thing. Receiving the data. It's 13.3% cotton. Now this piece of rag should have more cotton in it compared to these 2. So let's measure from this as well. Pressing the button, and it's showing 37.2% of cotton for this one. So it could distinguish between various degrees of glucose and also various degrees of cotton. Finally, I want to do a measurement from my hand to see what's the fat content on my body. So I'll go to the health, and there is a calibration curve for body fat, and then this should be of no problem because this is diffuse incoherent light from a halogen tungsten lamp, so it should not affect anything. It's not dangerous for your body. So I'll just press the button, and it says 22.7%. Actually, this result didn't come out to be well because it says frivolous, which means meaningless. So it didn't register the data properly. Let's try again. It says frivolous. We'll continue on this one. So let's try. Yeah, this one is registered. So 25.7%, and it categorized it as chubby. So basically, this shows that we can try to find different ingredients from fruits, fabrics, body parts, and also for medicines. You could also examine different types of pills for their ingredients. And there are other calibration curves as well, such as for polymers like plastics and oil, pharmaceuticals, and so on. I hope you find this video useful, and as I mentioned, the software is only for demo purposes. It's not available. You have to develop your own software. But this was an introduction to the capabilities of NIRVAScan photospectrometer. Thank you. Hello, my name is Raz Mani and I work for the company Allied Scientific Pro. So I'm going to introduce the cloud service for Allied Scientific Pro, which we call it NIRVA Cloud. So this is the main page for the cloud, and the idea behind the cloud is that customers could use it to upload their spectra and do their analysis if they want to do a PLS modeling or PCA modeling, and this way they could get the quantitative measurement from the ingredients that they are after. So this is the main page of the cloud. So I'll show you different features of the cloud. So you would go here, click on that main title, NIRVAScan Allied Scientific Pro, and just give it a few seconds for it to load. And this is the main menu that appears in here. So one thing to note would be the spectra. So if you click on the spectra, you will see that different spectra that has been uploaded will show here with the picture. So the idea behind the picture is that sometimes some vegetables have different species. For example, I can show you that tomato has, you have tomato on the wine, and Italian Roma tomato or beef steak tomato. So you want to be able to distinguish between these different types of tomatoes. And also you have the option to look at the small picture view. So you would look at the small picture view, which is easier to see all of them at once. All right. So aside from the spectra, there's also the NIR profiles. So usually for calibration, um, uh, for a model, you need something like 50 plus a spectra. So instead of uploading each spectra one by one, you can upload a spreadsheet and make a profile, and then all of those spectra will also go into the spectra section, and they are also part of the NIR profile. So for example, I'll show you the this particular spectra grapes calibration data set. This is for grapes. This is a calibration spectra that has something like 53, and you have the option to plot them all at once. So you can plot all these 53 spectra at once. Just give it a few seconds for it to plot. So it will show all the spectra at once and you can examine it. So here it is. You can see these are the 53 spectra with different bricks content. So you can remove the labels if you don't want to see that, you want to be able to see them better. You could look at the low resolution or high resolution pictures. Okay, so you can build models from these basically NIR profiles. So you can see, for example, if I choose this data set for grapes, I can go ahead and make a PLS model, and then I can use that to make predictions. So let's look at one of these PDPLS models. For example, if I go to the PLS model section, I'll see there is this one, the grapes. Let's look at the grapes PLS model. Okay, and you can see this is a grapes PLS model, and now I can apply this PLS model to a particular validation set. So I'll choose the validation set, and then I'll go to the very bottom and basically say apply the model to this validation set to see what kind of predictions do we get. So here you can see this is the predicted value versus the real value, and you get an R-square of 0.54. So you can also point at each data point and it will tell you the real value and the predicted value. So in order to improve the model, you can apply second derivative and Savitzky-Golay filters, and these are in this section. So you can apply these filters and run